In section 4.6, we are looking at optimization. So let's quickly start here by making a little love note to ourselves that optimization is an application of our first and second derivative tests. So we are looking for the dimensions that are going to maximize or minimize a particular situation. So it's all about the word problems here. So to get us started, I want to give you a little strategy to help you with solving optimization problems. So the first thing that you want to do is state what is given. You also want to ask yourself, what are we trying to optimize? So we say, what do we want to optimize? What are we trying to minimize or maximize? Step number 2, draw a picture when applicable. So to better help us understand a situation, it can be helpful to sketch a picture, particularly with geometric optimization. Step number 3, we want to define a constraint equation. So when we say define a constraint equation, we mean what is restricting you in the question that's given? So what restricts the situation? Next, you want to think to yourself, what am I trying to do? What am I trying to find? So in other words, you want to define an objective equation. So what do we want to maximize or minimize? Once you have both the constraint equation and the objective equation, we'll be able to start applying those first and second derivative tests. So in step 5, when applicable, we can use the constraint to rewrite the objective in terms of one variable and find the critical values. So we can rewrite that objective equation in terms of one variable. And then find the critical values. And we recall from our curve sketching section that when it comes to finding the critical values, we set the first derivative of our function equal to 0 and solve for x. So we're now ready to start looking at some examples.